One of 7 faculties with excellent and admired achievement at Yogyakarta State University is the Faculty of Mathematics and Natural Sciences. Faculty of Mathematics and Natural Sciences, Yogyakarta State University, scientific, critical, creative, and innovative.
Hi guys, we are from Group 2.
I am Fanza, Adillah, Amadea, and these awesome people next to me are
Dwi Retno Agustina,
Aini, Hanifah,
Amina N, Boseren.
So, here we are excited to present to you our project about geometry space and its application in life.
A few moments later.
Geometry space and its applications in life from Group 2, Mathematics Education C 2022. This is our member. The topics we will discuss are about definition of geometry space, history of geometry space, examples of geometry space and its applications, and conclusion.
Definition of geometry space. In mathematics, geometry space are a member of the geometric field. Geometry space is a three-dimensional plane. Because it is called a geometry space, making a spatial structure has a characteristic, namely having space or what is commonly called volume. Apart from having space or volume, a spatial shape also has sets to limit and has confines. The confines itself is formed from more than 2 sets joined together.
Next is the history of geometry space. Geometry of space has existed since ancient times. The following stages of history of geometry of space. First is ancient times. In ancient Egyptian times, around 3000 BC, geometry of space was used in land measurement and building construction. The Egyptians developed a method to measure the area and volume of three-dimensional objects such as pyramids. In ancient Greece, mathematicians like Euclid, or around 300 BC, developed the basic principle of the geometry of space in his famous work, Elements. Then, second, Middle Age. During the Middle Age, the development of geometry of space was not so significant. The main focus in mathematics at the time was algebra and trigonometry, while geometry of space did not receive the same attention. Third, modern times. In the 19th century, geometry of space underwent rapid development. Mathematicians like Carl Friedrich Gauss, Bernhard Riemann, and Nikolai Lobachevsky introduced the concept of non-Euclidean geometry. They saw that there are geometries other than Euclidean geometry that have different properties.
For 20,000 to present, space geometry continues to evolve and uplift in organization, arting content, and computer graphics. The development is more modern as geometry evolves to understand of topology and develop geometric applications. Geometrics and the method of in mathematics, one of its computer technology often advantage is often seen geometry in 3D. 3D monoreality speciality from ancient times to the present. Geometry of space continues to be an important subject in study in mathematics and arts by President of the Stay of Insight.
Examples of geometry space and its applications. First, cube. A cube is a three-dimensional geometric shape that has equal length, sides, and all its angles are right angles. Characteristic of cube. It has 6 square-shaped sides. It has 8 vertices or corners. It has 12 equal edges. All of its angles are right angles. Formulas of cube. Formulas for surface area and volume. The surface area of a cube can be calculated using the formula A equals 6s squared, where A is the surface area and s is the length of the side. The volume of a cube can be calculated using the formula V equals s cubed, where V is the volume and s is the length of the side. Examples of the application of the cube shape in everyday life is tissue box, ice cube, Rubik's box, buildings, and etc.
Tub or cylinders. A tub or cylinder is a three-dimensional solid consisting of two parallel circular bases joined together by a surface surface at a particular distance from the center of the circular base. The center of the two bases is joined by a line segment called the axis. The perpendicular distance between the base is the height or altitude, and the distance from the axis to the outer surface is its radius. Characteristic of cylinders. The first has two curved edges, one curved surface, and two flat faces. Second has two identical circular bases that are parallel and congruent. The third, the size depends on the radius and the height of the cylinders. Type of cylinders. 1. Right cylinders, axis perpendicular to the plane of its two bases. 2. Oblique cylinders, axis not perpendicular to the plane of its two bases. 3. Elliptic cylinders, based in the form of an ellipse. And last, right circular hollow cylinders, 2 right circular cylinders bounded one inside the other. Formulas of cylinders. Lateral surface area LSE of a cylinder. Formula LSE equals 2πRh, here P 22 divided by 7 equals 3.14, R radius and height H. Volume of a right circular cylinder. Formula volume equals P squared H. And total surface area TSA of cylinders. Formula TSA equals 2πRR plus H. Examples of the application of the tub shape in everyday life is oil drums, battery, milk cans, pipe, bottle, and drum.
The third is that there is a ball. A sphere or a ball is a space with curved side that has a shape without ribs. The characteristics of the sphere or ball are: first, a sphere has no ribs and no corner points. Then, a sphere has one curved side plane, which is the plane curve of the sphere. A sphere has a radius and a diameter. And the last, a sphere has a surface area and the volume. What are the properties of a sphere? The properties of a sphere that you need to know, namely the radius in the shape is infinite and has the same length. The ball or sphere also has infinite points and is close to each other on its side and has the same distance from the center point. The center point of the sphere is located right in the middle of the sphere and has the same distance to the side of the sphere. The distinctive properties of the sphere that are not found in other space, namely the absence of ribs and corner points. Additionally, a sphere has only one side that is a closed curve. Through this side, we can find out the surface area of the sphere. The area of a sphere includes the number of units that cover its outer surface. The size of a sphere can also be understood as the surface area that covers a single space. The formula for the surface area of a sphere is 4πr squared. The P is 22 seconds and the R is radius. As we have mentioned, a sphere has a volume like any other space. Volume is the capacity of space that can be occupied. The formula for the volume of a sphere is 4 3 πr cubed. The P is 22 seconds and the R is radius. Examples of the application of spherical shapes in everyday life are soccer balls, light bulbs, lollipop, and clocks.
Definitive icon in general icon A certain one vertex and two sides. One D in circular convex and then after sin iconical banking. Breaking icon room icon is geometry shape and there is the from even private with a circular base and then curved lid. Converters. It's in to circular and then center. The scan in center the pass and the converter its blanking house. One row in rip the house. One curved template of the icon. Needle formula. After when what it claiming his Hanifah suffered watermark and certified are well now there is claiming at one row. Therefore they nearly must have volume. The volume of frequent is be observed by replicating the way often they assert. Boseren are you to recursion with the Haken of the organ within formulated at a form. We Rwandan person. Right, there is vector. We can get to happen that everything I can control. On a second, I think the can be often multiplied in the area to best become. By the Haken equal return. Right, person produced and can 18. 80% of what icon also so. I can ask you to read the formula at the best area of the example is question circular that some open can prove it. Simply of the application of work in everyday life, we come with the ice cream in love and coding.
Okay, next, here it is example of operation of the geometry of space. The problem is find a cube with ribs 11 cm long. Calculate the surface area and volume of the cube. First, we write what we know. We know that the side length or S is 11 cm. The ask surface area and volume of the cube. The solution. First, we calculating the surface area. Formula of the surface area cube is 6 multiplied by the side length squared. The side length cube is 11 cm, so the surface area is 6 multiplied by 11 cm squared. The surface area is 6 multiplied by 121 cm squared. Then the surface area is 726 cm squared. Then we calculating the volume. Formula of the volume cube is the side length cube. The side length cube is 11 cm, so the volume is 11 cm cube. Then the volume is 1331 cm cube. So the area of the cube is 726 cm squared and the volume of the cube is 1331 cm cube.
Conclusion. Spatial geometry is a mathematical object that is three-dimensional and has volume content. The geometry of space has length, width, and height. Space building can be divided into two, namely flat set space buildings and curved set space buildings. Flat set shapes include blocks, cups, prims, and pyramids. Curved set shapes include tubes, cones, and spheres.
Alright everyone, that's a wrap on our presentation.
Thanks for watching. Bye.